Good evening, everybody. It's now 25 to 6. So I think with the flurry of people joining is starting to slow. So it's a good time to kick us off tonight's session. My name is Nick from the Chilterns Conservation Board. Just a little bit of me, a few bits of housekeeping before I introduce Ian to get the session underway, really. So some housekeeping things I'm sure we're all now familiar with Zoom, but we're going to turn everybody's cameras off and put everybody on mute. So we just make sure we've got as much bandwidth as we can for tonight's session. We try and limit as many Wi-Fi issues as we can, and also to make sure Becky has a clear one, no disturbance. So okay, we'll keep you on mute and your cameras off. Happy to take questions. Becky will run a presentation for about 45 minutes or so, and then we can take questions at the end. So if you want to put your questions into the chat, please. As we go, we'll work well, and as a team of us behind the scenes, and we'll make sure that we pass your question on to Ian to ask of Becky in the Q&A session at the end. So questions in the chat, please, if that's okay. We will be recording tonight's session as well, so we're quite keen for people who can't make it, we'll put the recordings up on our YouTube channel as well. So just to let you know that the session will be recorded, but if all your cameras are off, there shouldn't be any issues with your front room being on YouTube videos on that front, just to let you know. And we have arranged with BASIS for a CPD point for each one of the 6 webinars. So there is a BASIS accreditation point available for attendance tonight. So if you want to let us know afterwards if that's of interest to you, if you let Joe know, then we can send you the webinar code for you to claim your CPD point for tonight's session. So we can do that afterwards. And prize draw, we have a prize draw on offer. Becky's kindly offered to spend a day with the lucky winner, helping you to work through your own carbon self-assessment as well. So we'll be making the prize winner draw probably tomorrow, and we'll let the winner know in the next few days and logistics of how to claim the prize. So pretty enough for me in terms of logistics. Hope you have a great evening tonight. I will hand you over to Ian Waller now, our chair for the evening, to get us kicked off. Ian, over to you.
Hello there. Welcome everybody to number 3 of our sessions. Just let me get my screen right. This one we've decided to look at carbon, really to sort of set the foundations really for thinking about your soil in a different way, because we'll get to hear about sequestration and trees, but you know, healthy soils with good organic matter, whether it be arable land or grassland, but grassland has a bit more to offer, is really the key to locking plenty of carbon into your soil. So this is why we've chosen this subject tonight. For those who haven't been before, my name's Ian Waller. I'm chairman of Central Chilterns Cluster Farmers. I'm also a board member on the Chilterns Conservation Board, and I'm a keen regenerative farmer, so really looking at what's happening in the environment in a big way. Picture tonight behind me is, I'll just move slightly to one side, is a spider's web on the ground with a hole going down into the soil. So the sort of picture there is really saying the soil's a living web, and the spiders are probably quite easy to see. So there's a lot going on in the soil. So without further ado, I'll hand over to Becky for her presentation. Becky is, I've only known her a short while. I did take part in the Carbon Cutting Toolkit, and I've actually done the assessment myself, and I've took part in Soil Farm of the Year last year, and had quite long conversations with Becky over that because she runs the competition as well. So she's sort of the front person, if you like, for Carbon Cutting Toolkit. It's a really simple system to go through an audit. I hate audits, but I really enjoyed this one. That's made you smile anyway, that's good. And it really makes you sort of look at how your farming is impacting the soil and the organic matter in the soil, and obviously your carbon emissions. So without further ado, Becky, it's all yours.
Thank you very much, Ian. And yeah, it's lovely to be here this evening. Thank you very much for that introduction. And I say it's great to be here and see so many of you on the call, where we're going to start to navigate our way through the topic of how we manage carbon on the farm, have a little bit of look at some of the policy behind it, very much look at why we should be managing carbon on farm from a farm point of view, and then look at how we do that, as Ian said. And that's brilliant to have some testament that it's not too bad and it's not too scary a process, and hopefully there are some positives that come out of the end of it. So I'm going to start my presentation now, so hopefully you will all be able to see that. And then we're going to, there we go, and we're going to get going. So yeah, the topic that we're going to be focusing on tonight is carbon management on the farm. And I come from the Farm Carbon Toolkit. So we're a farmer-led organisation that was set up back in 2009. So we've been talking and banging on about climate change and carbon on farm for probably about the last just over 10 years now. And we were set up last time carbon and climate was very much in the focus of what was going on. And the reason that we were set up was because there was a lot of focus from the environmental side and potentially from the policymaker side, but there was very little out there for farmers who wanted to know what could they do differently? What was the impact of some of the things that they were doing on the farm, and how might they be able to change their practices to both reduce emissions and improve sequestration? So the Farm Carbon Toolkit's aim really is to try and encourage and support farmers and growers to reduce their greenhouse gas emissions, improve energy resilience and build soil health, but very much doing so with a focus on bottom line productivity and improvements there. We're a farmer-led organisation, so we have 6 full-time farmer directors who are all, sort of help guide where the organisation goes. And then there's me and a team, ever-growing team actually, of people who are delivering projects out on the ground. What do we have? Well, our 2 main resources of the organisation are our carbon calculator, which allows you to calculate the carbon balance on your farm. And put very simply, your carbon balance is the areas on the farm that are producing emissions, and we'll look more into where those emissions might be coming from in a minute. And then we take away from that those areas on the farm which are providing sequestration, either through carbon offsetting or through building carbon in your woody biomass, your environmental areas, or in your soils. And that gives you your carbon balance. We then have a toolkit that allows you to take that carbon balance in terms of that number and start to understand it in a bit more detail and start to think, well, what might be some of those practices or techniques that you can do to reduce the emissions and improve sequestration. We also run a variety of special projects. So as Ian said, and Ian was one of the finalists last year in our Soil Farmer of the Year competition. And that really aims to try and champion and promote those farmers who are, like Ian, are doing fantastic things around sustainable soils management, who are putting soil at the centre of their businesses and starting to understand that if we can manage soil in a way which starts to safeguard function, we actually get lots of wonderful things that flow from it. So that competition opens each year on World Soils Day, which is the 5th of December. And then the application window closes on the 5th of March. So for any of you guys on the call who are farmers and would like to be involved in that competition, you still have a couple of weeks before it closes this year, and it would be great to have you on board. And then we also are involved with the Soil Carbon Project, which is the largest farmer-led research project going on in England, looking at how we measure, monitor and manage soil carbon. And I'll talk a little bit more about that as we get through to the other end of the presentation. Where do I fit into it? Well, up until very recently, I wore 2 hats. So I worked out of Duchy College Rural Business School in Cornwall as an applied research leader, running a range of research projects down there, and also at Farm Carbon Toolkit as our sort of technical project manager. A lot of my work over the last sort of 15 years has very much been focusing on resource management, so how we manage our resources of our manure. So I was involved with a team of people that put together the Farm Crap app, which is an app to help manage manures more effectively on farm. I've done a lot of work in terms of diverse grass species and looking at the improvements of the use of diverse species and what they do in terms of building soil health and farm resilience. A lot of work on soils, as I say, the Soil Carbon Project. And back in 2016, I spent 2 years substantially increasing my own carbon footprint, flying around the world doing a Nuffield scholarship. And the aim of that Nuffield scholarship was really to try and understand in more detail how we communicate this issue of carbon and carbon reduction to farmers. Because if we sort of rewind back to 2016, we would have events similar to the one that we're having tonight, although pre-COVID we could all actually see each other in person, and we could do it in a village hall or in a pub or in the field. And we would find that actually we didn't get huge numbers of farmers that wanted to turn up. It wasn't something that was seen as an immediate business priority. If we fast forward to where we are now, it's amazing to see so many of you on the call tonight. And certainly carbon and agriculture's environmental impact is something that is really higher up everybody's understanding is receiving a lot more attention and is something that we can start to see the direct impact on our bottom line and our business from achieving. So then let's dive right into it. So what are we talking about when we're talking about greenhouse gas emissions from agriculture? Well, although a lot of the language and a lot of the discussion and the phrasing is very much around carbon, we talk about carbon footprinting, we talk about net zero carbon, we talk about low carbon farming. You can actually see from that pie chart there that emissions from carbon dioxide are actually the very small percentage of what's coming from agriculture. The vast majority of our emissions are coming from two other gases, from methane and nitrous oxide. And the combination of these three gases together that are made up from carbon dioxide, methane and nitrous oxide, together, agriculture is responsible for just under 10% of UK emissions. Now, you could say that for that 10%, we're receiving sort of, 90% of the attention or of the press at the moment. But actually, we are only just under 10%. And although we have three gases to deal with, and sometimes we can have interplays between those gases, so we might have practices that are good at reducing nitrous oxide emissions but might increase methane. There might be things that again are good at one but actually might cause an increase in the other. So we've got to look at how we can balance the opportunities to work with all of those gases. But here we also have one of our unique positives in the fact that there's a fantastic relationship between more efficient use of resources and actually a reduction in cost and a reduction in our carbon footprint. So there are lots and lots of things that each farmer can do to improve efficiency, to reduce cost of production, and to cut your carbon footprint. And these are very much the things that we should be focusing on first. But there isn't one magic management practice or one silver bullet that fits everybody. Each of your farms is a unique combination of what's under the soil, what falls out the sky, and what you do in the middle. And so we need to understand that we need a sort of multifaceted approach to actually start to address greenhouse gas emissions from agriculture and understand the contribution that can be made from our soils and carbon sequestration. We're going to need a multitude of different options, and each of those are only actually achievable when we engage with farmers and we start to help farmers understand what those might be and the practical implications of doing so. It's also really important to remember that we're not just producing these emissions for the sake of producing these emissions. We're producing these emissions because we're producing food. And quite often that's lost within this debate. Excuse me. It also can be difficult to measure. So we're not just dealing with one gas, we're dealing with three gases. So we've got to understand how they all interact with each other. We're also dealing with a complex biological system. So if you were to come along and hoover off all of the agricultural activities from all of our landscapes would still be producing emissions through those natural carbon and nitrogen cycles, which are a key part of how our ecosystems function. So we're never going to totally eliminate all emissions from agriculture. And that's then compounded by the fact that even when we're doing the best management that we can, the weather is sometimes against us. And sometimes that our soils will be emitting nitrous oxide, irrespective of what we're doing on the top, because it's not stopped raining for 5 months, or we've had a prolonged period of drought. And so we have to understand how we can start to work with nature and start to develop more resilience within our systems and within our farms to actually be able to adapt our businesses and also look at how we manage carbon. But undeterred by all that complexity, we shall continue. So, as I said to you on the previous slide, we've got those three main gases. We've got nitrous oxide, methane, and carbon dioxide. But where do those gases actually come from on farm? And I promise you, tonight's presentation is not going to be a doomy, gloomy climate change presentation, but this is my slightly one doomy, gloomy slide in the fact that there has been a lot of attention on methane and our much maligned ruminant animals, okay? Nobody's really focusing on nitrous oxide. And nitrous oxide really needs to be focused on because as a gas, it's a real issue because it's 298 times more potent in terms of its ability to thicken that blanket around the earth than carbon dioxide is. Methane's only 30. And again, there's discussions about how we account for methane, which I'm sure we can talk about later. But nitrous oxide is a big deal, and 80% of nitrous oxide emissions come from agriculture. So we are the main culprit in terms of emissions. Where do they come from on farm? Well, they come from how we manage our soils, our fertilizers, and our manures. So again, lots of opportunities to start to change and adapt the way that we work and the way that we manage those resources and start to look at minimizing emissions. Methane, obviously, from our cattle and sheep, by that process through which those ruminant animals are digesting that forage that we can't eat and turning it into something that we can eat. Often forgotten in the methane discussion, 98% of the methane comes out the front end of the animal, not the back end, like some of the media headlines lead you to believe. And that methane that's emitted from the animal is a loss of potential energy that could be used to grow meat or milk. So again, looking at efficiencies of production system can help to more effectively capture that methane. What's also forgotten in the methane debate is that actually our non-ruminant animals, so our pig and our poultry farmers, are also a source of methane from how they manage their manures and slurries. So again, it's not just all about our ruminants. And then we have carbon dioxide. And obviously carbon dioxide is the gas that most other industries are having to deal with, very much arising from the burning of fossil fuels. And on farm, that's been translating into how we use our on-farm diesel, electricity, and also how much cultivation that we do with our soils. Because when we turn our soils over, when we cultivate them, and we suddenly expose that soil that was covered up to the atmosphere, the life that lives in our soil and our soil biology suddenly starts respiring massively. And obviously that's a loss of carbon that goes back up into the atmosphere. On farm, we also have the opportunities to provide a carbon offset through generation of renewable energy, through looking at recycling of waste products. And then we also have the amazing potential that is carbon sequestration. And although it's very complicated, as I said, although we're dealing with all these different gases and all these different enterprises on farm, we are also incredibly lucky in the fact that our industry is one of the only industries that is able to provide a climate solution. In the fact that how we manage our soils, how we manage our crops, actually has the ability to suck carbon dioxide out of the atmosphere and hold it on our farms. And that's amazing because we're really unique in our ability to do that. So if we were to look just for a minute in terms of some of those, why should we manage carbon on farm? What's the real point? And looking at the bigger picture, well, we've got national targets to reduce carbon emissions from agriculture. We were very proud of the fact here in the UK that we were the first country to introduce legislation to reduce greenhouse gas emissions by at least 80% of those 1990 levels by 2050. And that was the Climate Change Act. Now, under the Climate Change Act in 2008, agriculture was seen as a bit of a complicated subject, a complicated sector, for some of those reasons I mentioned a minute ago, in terms of the fact that we're linked to food production, it's dependent on the weather, and we're dealing with those biological systems. So under the Climate Change Act, agriculture had a voluntary emissions reductions target, and that voluntary target was 3 million tonnes by 2050. Now, since the Climate Change Act, obviously back in June in 2019, we had the government who brought out their net zero legislation, which said that actually that 80% reduction wasn't enough anymore. We had to be at net zero. And for those emissions that we can't get rid of, we actually have to balance that out with some offsetting so that we're actually net zero. Now, after we had that came out saying that we were going to be net zero as a country by 2050, we've had the NFU report their aspiration for agriculture as an industry to be net zero by 2040. We have some local authorities and county councils who are looking at who have declared their climate emergencies and have set their net zero targets for 2030. There are various different supply chains and organisations within retail that again are starting to sort of try and want to take market share and start to report their carbon credentials by setting their net zero targets for even earlier. All of this means that there is an increasing attention on agriculture. If we look more widely than what's going on within the UK, then obviously we're signed up to the Paris Climate Accord. And in November this year, the big Confederation of Parties, which is the meeting where all of the global leaders who are dealing with climate change policy within their country come to the UK. It was due to happen in November last year in Glasgow, but because of COVID, it's been postponed a year. So there is a huge opportunity towards the end of this year for us to really start to demonstrate and show some of the great stuff that's going on. And there will be a lot of attention and a lot of focus as we get closer to November, with the government and policymakers trying to, come up with some of those good news stories that we can show off to the rest of the world in November. But if we focus down for a minute and look at, well, why should we manage carbon at a farm level? Well, it makes business sense. As I said, there's this really good relationship between more efficient production and actually better, more efficient use of resources and then cutting our carbon footprint. It allows us to be more informed and make better decisions, so we can start to understand our proximity as a business to net zero, and what some of those steps might be that we might want to start to implement to actually reduce emissions and improve sequestration. When we're starting to think strategically about what we might want to do within the business over the next year, 5 year, 10 years, we can then start to assess what the impact might be on our carbon footprint. It enables a positive narrative, and we really need a positive narrative for our industry at the moment. Quite often, the discussion around agriculture's environmental impact is being had for us by people that have an alternative agenda. There's a really good opportunity for us to start to tell some of those positive stories that are happening out on farm and start to use some of the data that's coming out to start to show some of those efforts that are being taken. It creates more resilient businesses and it helps us to future-proof. And that whole process starts with doing a carbon footprint, because that old adage of you can't manage what you don't measure is really, really important. And put very simply, identifying the carbon footprint of a business is that first step in being able to quantify the contribution that your farm is making to climate change. And although carbon footprint can sound like a bit of a sort of scary term, all it's really referring to is the ability to be able to quantify the amount and the source of those three gases, so carbon dioxide, methane and nitrous oxide, that are being emitted from a farm, and then highlights areas where you might make improvements or changes to reduce greenhouse gas emissions. It does a similar sort of thing for sequestration and offsetting, so looking at where you're currently providing that offset or sequestration on farm, and looking at where you might be able to change things to improve it. It allows you to be more aware and make better decisions. So actually, as I said earlier, once you're starting to look at some of the things you might be considering on your farm, you can start to say, well, what would the impact be of doing this or doing this? What might be some of those management strategies that I can employ to start to move my farm in the right direction? But those metrics that you use need to be relevant, so they need to make sense to your business. They need to be practical, so they need to be asking you questions which actually allow you to start to create a narrative and an understanding of what you can do next. They need to be consistent. And consistency is something that we've had a bit of an issue with in carbon footprinting in the past. The current standards that are available for carbon footprinting were last updated back in 2012, and that's the PAS 2050 specifications. Now, obviously, since 2012, our understanding, our knowledge and research has moved on dramatically. And so it's really important that we have updated specifications and standards that reflect that new knowledge. Because currently we have a range of different calculators. There's three mainly that farmers can use, and they will give you slightly different results. And they will do that because they take into account different things. So some include sequestration, some don't. Some use different assumptions on those figures. And so we need that level of consistency in order to sort of allow us all to move forward. And they also need to be that first step in informing behavioural change. So the idea is that the actual process of doing your carbon footprint isn't so hideous that you have to go and lie down in a darkened room for 3 weeks to get over it. It's that first step in then being able to say, so what's this information telling me and what can I do differently? And one of the other things that we have quite often with carbon is that although carbon footprints are really, really useful in terms of being able to understand environmentally and economically what's going on, carbon as an entity can be quite difficult to visualize and become familiar with. So like I was saying earlier, agriculture's target under the Climate Change Act of reducing its emissions by 3 million tonnes. Well, actually, it's quite difficult to even visualize what a tonne of carbon dioxide looks like. We can't see these gases being emitted. We can't see it being sequestered. So actually understanding and getting a handle on how carbon flows through the farm can be slightly tricky. So you can see there that there's 8 different things on the screen that all produce emissions. You can see we've got 10 tonnes of concrete, we've got a dairy cow, we've got 1,000 litres of diesel, a tonne of ammonium nitrate, some pigs, a tractor, a tonne of winter wheat, or some cake that we might feed some livestock. And if you were to start to think about which of those would provide the most emissions and which of those might produce the least emissions, sometimes it's quite an interesting way to sort of try and work out how you might rank those. And when we start to translate carbon into these terms that we're, these sort of, ways that we can understand it in a lot more detail, it starts to make it a bit more real and a bit more tangible. So for any of you that are interested in terms of how that list would rank out, well, actually, I've been a little bit naughty in the fact that tractors have a lot of embedded energy in their manufacture, but we actually depreciate their carbon cost over 10 years. So actually that tractor would only be providing 4.4 tonnes of carbon dioxide equivalent per year. Now you can see that tonnes of CO2e, that's the common reporting language that we use for carbon footprinting. That's not to say that all of the emissions are coming from carbon dioxide. It's just that the emissions that are coming from nitrous oxide and methane, we translate into a carbon dioxide equivalent so that we can talk about everything in one language. But you can see there that at the top of the list are things like diesel and fertilizer and our cow. And at the other end of the list, you know, concrete quite often surprises people. People often think it's got a higher carbon footprint than it has. But we've got those, you know, the winter wheats and the feed for the animals as well. And you can see there on the other side of the screen, the potential ability of our soils to be able to capture some of this carbon. And we can see the comparison there with different types of forestry and other environmental features. So we have a carbon calculator, as I said at the beginning of this presentation. It follows the same USP of the organisation in that it's developed by farmers for farmers. It is completely free to use for farmers. It will never sit behind a paywall. You can create as many different versions of your footprint as you like. You can spend from now until the end of lockdown if you want, you know, modelling different scenarios. That's fine. You can create as many as you like. It accounts for soil carbon sequestration, and the way that it does that currently is that you have to have 2 time points where you've got soil organic matter analysis that you can enter into the calculator, and it will calculate the difference and what that's meaning in terms of additional carbon sequestration. Now, we totally accept that for a lot of farmers, they might not have those 2 time points where they've got that information. So one of the things that we've been doing for the last 3 years is running the Soil Carbon Project. And that information and that data that we've been collecting through there is now populating a model that sits behind the calculator. So if you've got your data, it's brilliant, you can put it in. If you haven't got data, you can sort of use the practice-based approach, which says I'm on this soil type, these are some of the practices I'm doing, this is my current cropping. And it will give you an understanding and an idea of what that might be providing in terms of an additional carbon sequestration. It allows you to monitor your footprint annually. So ideally you do this on a yearly basis. It provides your footprint as that carbon dioxide equivalent, but within that you can see where the different greenhouse gas emissions are coming from. It includes the new methane methodology. So for any of you livestock farmers out there, you might have heard about this work that was done looking at the fact that methane doesn't behave in the same way as carbon dioxide and nitrous oxide in terms of their more long-lived climate pollutants. Methane has this initial pulse and then breaks down into its constituent parts. And so if we account for methane, thinking that it sort of goes up into the atmosphere and it stays there at that same level, then we're potentially overestimating the impact of methane. And you can do that within the carbon calculator. You can understand the impact on your carbon balance of using the traditional way of measuring methane, and then also assess the impact of this new metric. And we launched a new version back in January last year where we'd spent a lot of time and effort looking at how we could make it more user-friendly to use. The emissions factors for the calculator are updated every year. So as and when new research comes out and DEFRA publishes their emissions factors, they are updated you know, on an annual basis. But we spent a lot of time last year looking at how we could improve the usability of it and make it easier to use. So how do you do it? Well, you log in and you register. That then information is just for you. It doesn't go off to the RPA or DEFRA or anybody else. It's just so that you can collate all your reports in one place. You have to collate your data first. And at this point, I will hold my hands up and say that is the bit that even for saddos like me that do this all day is quite boring. You have got to collect quite a lot of information to do your carbon calculator. That data needs to be collected in various different categories. So in fuels, which is information on your on-farm diesel, electricity, all those sort of things. Materials is what you use on the farm in that 12-month period. Inventory is the carbon cost associated with your buildings, your machinery, and your tractors. Emissions from crops are very much looking at any annual cropping that's going on the farm, whether you're using cover crops, any of those sort of things, that all goes into cropping. Inputs is obviously your fertilizers and your ag chem. Livestock is the emissions from the animals themselves and then any feed that you're feeding them, and then also what you're doing with their manure. Waste, again, what you're doing with rubbish on the farm, distribution, and then sequestration. And you enter your information into all of those different categories. As you can see here, this is a fuel. That donut in the middle is showing you the results for this farm's fuel. So you can see that 53% of the emissions associated with that broad category of fuel are coming from red diesel. That's very common. You know, a lot of the emissions in the fuel category tend to come from red diesel. And as you start to populate the data into each of those categories, you can see that on the right-hand side there, you'll get a breakdown of where your emissions are coming from within those broad categories. And that gives you an idea of where you might want to focus in terms of looking at concentrating any change in management. So you go through all that process, you enter all your data into all of those different categories, and then you get to the exciting bit, to the big reveal. And for those of you that can remember that I was saying at the beginning of the webinar, this is your carbon balance. And your carbon balance, very simply, is your emissions, take away your sequestration, which gives you your carbon balance. And unlike your bank account, a negative number here is a good thing. because that means that this farm is carbon positive, because this farm is sequestering or pulling out of the atmosphere 816 tons more than it's emitting. And that's brilliant. And only through the process of going through your carbon footprint can you actually get to this point and say, well, that's great. Is this as a result of what I do every year, you know, just as an average farm year? Or have I done something specifically different this year that's taking account of that big rise in sequestration? And if it's that this is, you know, just an average year and this is taking account of what you're doing normally, then how am I going to potentially start to get rewarded or incentivized to continue farming in that way? But you can't have any of those interesting discussions until you've actually been through and put the information in. So interpreting your results is a key part of the process. It allows you to evaluate where you are now and plan for where you might want to go in the future, both in terms of improving sequestration and reducing emissions. It gives you a baseline, puts a line in the sand and says, this is where we are now, allows you to be more informed and gives you that evidence to change management. So once you put your data in once, actually, when you then come to do it again in year 2, you can just copy last year's. So again, that process is really only hideous the first time you do it. And you can start to say, well, what would the impact be if I changed my management? What would the impact be if I changed my grazing pattern? Or if I changed my cultivation? Or if I planted a cover crop? Or if I changed the type of fertilizer I was applying? And you can model those scenarios within the calculator. So that's how we measure it. But then what do we do about it? And what might be some of those things that we can look at? Well, that process starts by understanding, well, where do our emissions come from? And although I said at the beginning, there's no such thing as an average farm, if we were to pretend for a minute there was, then this is where the emissions would come from. And you can see there on an arable farm, 60% of emissions come from fertilizer, and that's nitrogen fertilizer, both from the process of manufacturing nitrogen and then also how you deal with it and you manage it when it comes onto the farm. Now, nitrogen has an issue from two sides. Firstly, the actual process of making nitrogen fertilizer is incredibly energy intensive. So that Haber-Bosch process takes a lot of energy to produce nitrogen, and that's a carbon cost. One of the other issues with that process is that one of the byproducts of it is nitrous oxide, which is also a greenhouse gas. Then, as I say, when it gets on farm, what you do with it in terms of how you apply it also has emissions associated with it. On an arable farm, we've then got 20% of emissions that are coming from fuel use and field operations. So that's cultivation and tillage, that's diesel usage to do those things in the field. About 10% from P&K, or manures or lime, just under 10% coming from sown seed, so the emission of getting the seed to the field for you to plant, and then a small percentage from crop protection. If we look at a ruminant farm, about half of the emissions are coming from the animals themselves in terms of that process of enteric fermentation. Another 20% are coming from manures, so from how you manage, store and apply your manures. About 10% coming from fertilizer, about 10% from imported feed, and then about 10% from power and fuel. And if we look at some of those key actions or those groups of actions that we might want to focus on, these would be some of those. So optimising livestock performance for livestock farmers, looking at how we might focus on soils, fertilisers and manures, looking at energy and fuel use, looking at developing renewable energy if that's an option, and then also looking to maximise the carbon assets on farm. So if we just focus briefly on each of those topics. So in terms of optimising livestock performance, as you can see from that pie chart on a ruminant livestock farm, 70% of emissions are coming from the animals and their manures. So there's lots of scope there to start to improve efficiency and reduce emissions. And some of these things will be things that you're already trying to do anyway as part of running a profitable and efficient livestock business. So very much focusing on animal health, looking at making sure that you're on top of endemic diseases, you're on top of things like lameness, and those are the things which are actually meaning that your output isn't optimized. Looking at reproductive efficiency, so looking at lambing percentages, looking at calving intervals, all those things which mean that the animal is more productive and there's less methane that's being emitted when there's no productive capacity being met. Looking at feed conversion efficiency, really important. There's lots of really exciting work going on at the moment looking at how to reduce methane. They found that methane is actually a heritable trait. So actually you can breed and it's one of the traits that actually is quite persistent in terms of breeding for low methane. The other really interesting thing they found with that is that actually there's a really good link between those animals that are producing less methane tend to be more productive. And again, it's back to what I was saying at the beginning, and the fact that those animals are more effectively capturing that methane and releasing less of it through enteric fermentation. So there's a lot of work going on there. There's also a lot of work going on looking at various supplements. But as I say, if we think back to what I was saying at the beginning, in terms of actually how we account for methane is part of that much bigger picture. But also looking at how we manage and store our manures, how we can integrate that with fertilizer. All of these are options to reduce costs and also reduce greenhouse gas emissions. If we look at soils, fertilizers and manures, we could spend a whole evening talking about this topic, but very much focusing, if we're looking at reducing carbon emissions, looking at trying to reduce carbon that we're losing through tillage, and looking at trying to feed more carbon into the system by looking at inputs of organic materials, of crop residues and all those sort of things. If we look at nitrous oxide, the biggest thing we can do with soils is improving soil structure. If we've got soils that are sitting wet and compacted, those will be much higher risk of emitting nitrous oxide. Looking at maximising the performance of our crops and our grass, so making sure that we've got optimal conditions for photosynthesis so that actually our plants can put out their solar panels, they can take those things out of the atmosphere in terms of sunlight, air and water, and they can turn that into green leaf and they can do photosynthesis, and actually that's pumping carbon back down into the soil. Really important to look at using optimal use of organic materials and of organic manures. Legumes, our atmosphere is 78% nitrogen. Let's try and fix some of that and use that. It's really important. Looking at fertilizer management, both in terms of the type of fertilizer, the rate and the source, and then also looking at some of that new technology around inhibited fertilizers and looking at abated fertilizers. Energy use, again, quite often some of that boring stuff that really gets left out. Energy and fuel use can provide really good savings, both in terms of carbon reduction in carbon emissions, but also financial savings. And again, dig out your energy bills, do an energy audit, look at where you're using fuel, things that you can all do to improve that, looking at maintenance of machinery, looking at timer switches, insulation, yard lighting, all of these things. It doesn't have to cost huge amounts of money, and actually there are really good opportunities for financial savings. Renewable energy, if that's an option for you, and also worth considering renewable heat. But then what about sequestration? Because all of those things that I've just been talking about have very much been focusing on reducing emissions. But actually, what about that positive side that I spoke about at the beginning? Well, let's start by looking at trees, okay? And trees are an incredibly important opportunity for carbon sequestration. But you would almost be forgiven for thinking at the moment they're the only one. If you look at some of the discussions that have been going on, and we're going to plant 1 billion trees, we're going to plant 1 trillion trees, and if you start to think, well, why are we focusing on trees? Well, we're focusing on trees because it's very easy to measure. There is a lot of research and work that's gone on in the past, looking at actually how much carbon a tree holds, both in terms of the species of tree, how old the tree is, how much of that carbon is held within the woody biomass, within the canopy and underneath within the soil. And all of that is really well known. So it's very easy for policymakers or for others to think, well, actually, what's our total emissions and how many hectares do we need to plant in order to offset those? For us on farm, we also have a really good resource in terms of above ground carbon with our hedges. Hedges are a fantastic source of carbon sequestration and something that we can all do and we can all manage, which doesn't just help with carbon sequestration, it also helps with habitat creation and biodiversity and all those other things as well. So the things that go into how we understand what's going on with carbon sequestration within hedges is how wide they are, how tall they are, and then also how you manage them. So how frequently you cut your hedges will also have an impact on carbon sequestration. But then we've got soil, and it's that often overlooked opportunity. And it's often overlooked because it can be quite complicated and it can be quite difficult to measure. And one of the other things that quite often adds to the complexity is that there are two terms that are quite often used. We have soil organic carbon and soil organic matter. And they're quite often used interchangeably, but they are fundamentally different in the fact that if you think about what makes up your soil, and if you were to put it on sort of a pie chart, you would see that 45% of your soil is made up from minerals. So it's made up from the proportion of sand, silt and clay that goes into your soil type. If you go to the other half, 25% of it should be water and 25% of it should be air, and that's in a well-structured soil. That remaining 5% is soil organic matter. And soil organic matter comprises everything that is alive or has been alive that sits within your soil. Now, not all of that soil organic matter is soil organic carbon. Soil organic carbon is responsible for 60% of that soil organic matter. And it's mainly decomposing plants. So it's really important to just look at the difference between those. The soil organic carbon is incredibly important. And even if you're not interested in soil carbon from the ability to provide a climate solution, soil organic carbon improves yields. So we should be looking at it from an agronomic productivity point of view. And this is some work that's been done by Ratan Lal over in the States, who's one of the very early proponents of soil carbon. And he said that found this really good relationship between, if you can improve organic carbon, you can improve soil quality, because you can improve all those things that actually you need and help drive productivity. You can improve nutrient use efficiency and infiltration and water retention and nutrient cycling. And you reduce all those things that you don't want in terms of erosion and runoff and compaction. So if it's so good, how do we do it? Well, traditionally, when we were looking at carbon footprinting, the only way that we could increase soil carbon was actually to change land use. So if we were an arable field, we turned it into a grassland. If we were on a grass field, we turned it into woodland. And that change from one land use to the other is what gave you that additional heat sequestration. But we all know that within those very broad categories of land use types, there's a massive range in terms of how they're managed. Broad things to think about is about reducing the amount of carbon that's leaving the field through reducing erosion and reducing tillage, and feeding more carbon into the system in terms of those organic amendments and crop residues. It's also worth looking at how your rooting depth and actually what your species choice and all those sort of things, because actually if you can put that carbon further down the soil profile, it's then less likely to be re-released. And these are some of the things that we've been looking at within the Soil Carbon Project. And the Soil Carbon Project really came about from a couple of different things, really. One of them was the Soil Farmer of the Year competition. And in the early years of the Soil Farmer of the Year competition, and we still do now, we have farm walks on the top 3 farms. And we would go out, they're always brilliant events. They're always led by the farmers, and they take interested farmers around and show them some of the changes that they've been making on the farm and the results. And in those early years, what we would quite often happen is we'd go out into a field and, we'd look at a fantastic field of wheat or grass or whatever it was. And the farmer would say, look, my field's transformed. It's amazing. It hangs on for longer when it's in the drought. It takes water better when we're in the wet. I can dig a hole and I can show you all the worms. My crops look brilliant. It's just fantastic. And my question back to them was always, well, it looks brilliant, but have you got any sort of data or understanding of what it was before and what it is now? Did you take any baseline soil tests? And the answer very much was always no, we didn't. And so when I sort of asked them a bit more detail as to why not, the answers that would come back would be very much around, well, I didn't really know what to test for. I wasn't convinced that the tests that we've got are that good, and it just wasn't something that I saw was very important. At the same time, I'd be doing sort of events like this or similar, and people would say, well, I've just stopped ploughing and I've moved over to a min-till system. How much carbon is that holding me? Or I've just planted a cover crop. How much carbon is that holding me? Or I've changed to a rotational grazing system, or I've started to incorporate, herbal lays into my grasslands. How much carbon is that holding me? And the horrible answer that I would always have to give them back was, well, it depends. It depends. What were you doing before? What's your soil type? And so those sort of things coming together meant that we really wanted to try and understand what was going on with soil carbon in a bit more detail. So the Soil Carbon Project has 3 main aims. The first one is to really understand, how do we measure soil carbon? Is it just as simple as doing soil organic matter? Do we have to do soil organic carbon? How many samples do we need to take? How deep do we need to take them? What's the link with some of those proxy measures? So really trying to understand how we measure it. The second aim is then to say, well, now we know how to measure it. What are those management practices that make a difference? So I can start to answer some of those questions. And the final thing is to say, well, actually, what's the potential for soil carbon to actually provide a really good part of that whole farm carbon footprint and help us to transition to carbon positive farms? So we're working with 100 farms across England. And each of those 100 farms, we have between 4 and 6 fields that we're testing. What are we testing? Well, in each of those fields, we're testing soil organic matter and soil organic carbon at 3 depths, so 0 to 10, 10 to 30, and 30 to 50 centimetres. If those fields are bigger than 15 hectares, we subdivide the fields as well. We're also testing on a smaller number of fields some of those new things that we can test. So we're testing carbon to clay ratios, carbon to nitrogen ratios, total organic carbon content, how carbon varies across a field, and testing the difference between labs. We're taking bulk density at 3 depths per field so that we can also calculate the carbon stock, the tons of carbon that are held under each field. And at 3 points, we were also looking at proxy indicators. So we're looking at soil structure and worms, infiltration, aggregate stability, and biological activity. So a couple of things that we're finding in terms of testing advice, it's really good to start testing. If you say the best time to start was 20 years ago, but the next best time to start is now. It's really important to be consistent in terms of the lab that you use, the same time of year that you take the samples, and the depth that you take the samples. If you want to supercharge that process, you can also GPS log with your phone those points across the field that you're taking the sample at, so that then when you revisit that field in a few years' time, you can take account of those same points again. We've also found a really good link between soil carbon and aggregate stability. And aggregate stability is a fantastic test. You can all do it. You don't need any expensive bits of equipment, and you don't need to send any samples off to a lab. Go out into your field and dig a hole and grab a handful of soil. Put that handful of soil on a sunny windowsill or in an airing cupboard to dry for a couple of days. And then take out a couple of small lumps and submerge them in water. And just watch what happens to them. And it's a bit like dunking a biscuit in a cup of tea. What you want to happen is you want your soil to behave like one of those biscuits that you can dunk time and time again and it stays together. Because that glue that's holding your soil particles together is a key component of soil carbon. So you can see the difference there of those two soils that are on the screen. You can see that grassland soil at the top, which has got a high soil organic carbon content, where it's sticking together. And you can see that arable soil at the bottom, and it doesn't always have to be the difference between grassland and arable. It's just these examples. But you can see it's a bit like one of those biscuits that you put in and it just goes bleh, and you get that sludgy mess at the bottom. So what does all this mean? Well, it means that we've now got a way of measuring soil carbon that's verifiable, scientifically robust and cost effective, which is great. We've still got some questions and things to think about what do we actually pay people on? Do we pay them on soil organic matter? Do we pay them on soil organic carbon? How often do we have to test, and how accurate do those tests need to be? And we have different global models that are currently working that take account of carbon sequestration payments. And they do that in a variety of ways. In Australia, they have a measurement-based system. In America, they have a model-based system where you get paid a set amount for doing practices, a bit like our stewardship schemes, on a number of hectares. In New Zealand and in Canada, they have a sort of hybrid model that does some measurement and some modelling. It's also really important to remember the difference between carbon stock, so the amount of carbon that's held under our soils, under our fields, that we have to look after and protect and try and not let go back up to the atmosphere. And then the additional carbon that we can pull in through sequestration. And they are two fundamentally different things, and they may well be paid for completely separately. And there's lots of private finance interest at the moment as to how farmland and farmers that are farming in a regenerative manner can provide one of those offsetting solutions for other companies. But in terms of payments for farm carbon, despite the fact that there is that major interest, there are very few actors currently that are paying farmers for carbon credits. There's about 645 projects within the Woodland Carbon Code. However, there are several schemes that are due to be piloted for soil carbon this year. There's some, gentle farming, which is looking at a sort of, you can pledge a number of hectares and you have to farm those using a set of, a set of farming principles. Soil capital, which is currently working in Europe and is looking to come over into the UK very soon. Indigo Ag, which is obviously from the States, and others. We have a range of codes that support that offsetting market. We have a woodland carbon code, which is responsible for tree planting. We have a peatland restoration code, which is very much looking at how we restore peatland. But we don't currently have a soil carbon code. But there is a group that is working together currently to try and develop that and develop one that works for the UK. So just to conclude then, in terms of using carbon calculators are a tool that can be used to plan future management and baseline where you are now. It helps you to understand, well, this is where we are now. How close are we to net zero? What might our opportunities be? Do we have opportunities to start to look at improving soil health and reducing emissions? It's really important to know the background to the one that you're using. So choose one that works for you, understand what you might want to do with the results. But it's also really important to remember that none of them are perfect. None of the carbon calculators, ours included, have got it all sussed yet, because it's an evolving science. But just because we don't have all the answers now, it doesn't mean that we don't have to start somewhere. And it's really important to also start thinking about how you might baseline soil carbon ready for the future. And I think that's it. So thank you ever so much for listening. I'd be more than happy to answer any questions.
Thank you, Becky. That was really interesting, as I thought it would be. So you haven't let me down on that. So we've got quite a few questions and we've tried to block them together as much as possible as ever. So okay. Sort of reoccurring one really is how long does CO2, methane last in the atmosphere, and what's it, you know, when do they break down? And I know you did briefly touch on that, but just the three main ones. And I could also chuck in ammonia there, because that's very topical at the moment as well, if you know the answers to those.
Yeah, so I mean, ammonia is an interesting one, because obviously it's not technically a greenhouse gas, which is one of the reasons why we've suddenly got this you know, this real policy interest in terms of looking at you know, it wasn't a water pollutant and it wasn't a greenhouse gas, so nobody was really paying attention to ammonia. And then suddenly, when all the air quality regulations came in, they realized that ammonia was a big deal. In terms of how those gases are in the atmosphere, as I said, the way that we currently account for greenhouse gas emissions is that we use this thing called global warming potential 100. And that accounts for the ability of those gases to thicken that blanket around the Earth and cause global temperature rise over 100 years. And so the way that we do that is to say carbon dioxide goes up and it stays there at that same level over that 100-year period until something takes it out of the atmosphere, okay, until we use one of those sort of, you know, biological carbon capture measures that we can use to take that out. Nitrous oxide does the same. So nitrous oxide is 298 times more potent. So if you were to plot it on a graph, it'd be up here. And again, it stays there. It's a long-lived climate pollutant. So it stays there in the atmosphere at that same concentration for 100 years. And this is where the difference is then with methane, in the fact that methane doesn't behave, isn't termed a long-lived climate pollutant, it's termed a short-lived climate pollutant. So methane has an initial pulse after 9 to 12 years, and then breaks down into its constituent parts, which is carbon dioxide and water, and is reabsorbed back into the system. Now, under the GWP 100, so that sort of global warming potential over 100 years, we were saying that methane was 30 times more potent, and then it was at that straight line until the end of year 100. So what this means with this understanding of how methane behaves slightly differently is that actually that using that sort of 100-year time frame is actually, you know, overestimating methane. The work that was done by Oxford University was very much looking at a macro level. So it was understanding the impact of global livestock numbers on global temperature rise. So it was sort of 100 times removed from a farm, and it was looking at how changing global patterns of livestock numbers would impact on global temperature rise. Now, what we've managed to do through the calculator is start to translate that down to a farm level. And what it means for livestock farmers is that if your livestock numbers are staying the same, so if you're not increasing your herd or your flock, but your numbers are staying the same, then actually your methane is in all likelihood in balance, because that methane that's being broken down actually matches that methane that is currently being emitted from your herd. So the way that we understand that and we calculate that is we have to understand livestock numbers now and livestock numbers in the past, so whether your numbers are staying fairly the same or whether they're dropping or going up, and that will then make an impact. Now, the really interesting thing to watch with the new methane metric is that it's fine if your numbers are staying the same or they're gradually going down, but if your numbers are going up, it doubly whacks you because you're adding new methane into the atmosphere. So, you know, it's fine if your numbers are staying the same, but if you are increasing your herd, then you're putting new methane in, and that's obviously quite potent.
Right. Sounds quite technical, all that, but I did get to the grips of it. And we did have a really good presentation from the professor who did that work at Oxford University last year at NFU conference. And that was really engaging, that, you know, just because there's so many bad stories out there about farming's terrible, whatever you do. And it's not quite like that, as you described. So the next questions, I'm sort of going to lump two together here, really. How do you think farms could be rewarded for having good soil and organic matter? And also, to go along with that, do you think DEFRA are looking at carbon assessments under environmental land management? Have you had any sort of conversations with them on that?
Yeah, so in terms of that second point first, they have been looking at how carbon assessments, and in terms of whole farm carbon assessments, so carbon footprinting, could well sit under ELMS. They've currently given it the really imaginative title or acronym of a FERP, which is called a Farm Emissions Reductions Plan. Now, I do hope that by the time it comes to fruition, we've got a better name for it than a FERP. But that is what they were currently looking at. And again, because there's a real need to assess where farms are currently and then look at some of those mitigation options that can move forward. In terms of rewarding farmers for looking after soil organic matter and soil organic carbon, yes, I think, and this is what I was sort of trying to allude at the end of my presentation, I think we've got two distinctive areas there. We've got protecting the carbon that we've already got, and that will probably come in a sort of a bit like we have now from Natural England, in terms of a sort of payment to protect that carbon. And then we've got additional carbon that we can sequester through change in management practice. And it may well be that that comes from a sort of private finance source, and there's lots of companies out there currently that are desperate to work with farmers and actually use those as their offsetting, because it's really important that we recognise that protecting the carbon we've already got is a key part of it. Because, I know when I used to do some lecturing at Duchy College, and they used to sort of say, well, the best thing to do is to just go and plough it all up now, and release it all, and then we're starting from a lower baseline that we can then sequester it all back in again. And obviously we don't want to do that, because we need to sort of remember the bigger picture reason as to why we're doing this. It's because we're actually trying to pull carbon out of the atmosphere rather than just rather than start by releasing it back up. So I think we need to sort of differentiate those two pots there. And I think there will be a protection payment, and that may well be through regular testing to check that the levels aren't going down, and then a payment for that. And that will also hopefully reward those farmers that have been doing some of these practices for a lot longer than others. So again, those farmers that have already been looking at those practices that are building soil organic matter, it means that they can hopefully be rewarded for that, as well as looking at that additional carbon that can be pulled in.
Yeah, I'd sort of clarify with that, because a lot of the DEFRA meetings that I've taken part in, they will be looking at historical stuff that you've actually already been doing, that they will be rewarding you for things you've already got in place, rather than what was happening under the old schemes. They'd pay you to almost plough something up to then put it back in again to what it was, which is a bit ridiculous situation. So that's, that is going to help us, I think, going forward. This one sort of, is grassland better at storing carbon than woodland?
It can be. It can be completely. It all depends on how you manage it. So I think what's been sort of the case up until now is that we've had a very simple way of understanding how much carbon is held within a tree. And so when we're doing our carbon accounting, as it were, we can account for a hectare of woodland, and we can depend on the species and the age of that, and we know what that's doing. But grassland hasn't been afforded that same luxury. And one of the reasons for that is that a lot of the early work and research that's been going on looking at grassland has said that actually it's quite stable. It's not pulling in any additional carbon. It's just like I was just saying with that other question, it's a carbon stock that we have to look after, because it's perennial in nature, because we're not cultivating it or doing any of those sort of things. But as we start to learn more about grassland, and especially permanent pasture and that sort of thing, we can see that actually there is still scope to improve that. And what we're starting to see is that actually that it's also looking at where that carbon is distributed within the soil profile and how you manage that grassland. So it's a bit like saying, well, grassland isn't just grassland, and you have to understand a bit more detail. So there are some grasslands that actually won't be sequestering as much as woodland, because they're not managed in a way which is optimizing photosynthesis and is actually starting to allow that grassland to continue to sequester carbon. But there are other grasslands that are doing phenomenally amounts more than woodland in terms of their sequestration, because they're being managed in a way to optimize that soil health through things like having diverse grass species which have much deeper rooting species. They might be practicing tall grass grazing and looking at that ability to actually improve grassland utilization and actually start to trample some of that material back down. So grass is quite a broad definition. One of the things which is coming, which is really good for farmers, is that there is going to be an understanding and a sort of provision made for grassland like we have woodland. What we can also then do is start to supercharge that with understanding that additional carbon sequestration that's going in. But there is a growing realization that grassland is an important habitat for carbon, and we are getting better at measuring that now.
I'd sort of quantify some of that as well, because there's quite a bit of woodland around here. It was planted in the last 15 to 20 years, hardwood, that the squirrels have absolutely decimated, and those trees are never going to sequestrate much carbon because they'll probably fall over within the next 10 to 20 years. And just when they start to, in theory, should be actually capturing quite a bit of carbon, they're going to be rotten through the heart and branches dropping off them and not actually delivering what the standard woodland portfolio could do. So it's all down to management, as you rightly say. And the other thing that was mentioned in our first presentation with James Rebank, mob grazing, trampling some of that residue back into the surface and feeding the soil, exactly the stuff that's produced when it stays there, doesn't even go for an animal and gets trampled back in and enhances that carbon through that way as well. It doesn't have to go through an animal.
Definitely, and you make a really good point about managing woodlands. I know there's been a lot of sort of knee-jerk tree planting, and actually it's not much thought has gone into species, density of planting, all that sort of thing. So we're not getting what we should be getting from some of those projects.
So this one, as I quite often say, I think I know the answer to this one, but what's the simplest, earliest way to win and to help take the first steps in completing an assessment?
In terms of a carbon footprint assessment?
Yeah.
So there's all those different. It's just collect the information and just put it in. And there are sort of degrees of doing it. So if you're a livestock farmer, then obviously the categories where the majority of your emissions will be coming from are fuels, inputs, unless you're organic, livestock, cropping. Which one have I missed? Fuels, inputs, livestock, cropping. So focus on those 4 to start with, and then sequestration. Okay, don't worry too much about inventory and materials. Those are the sort of extra bits that you can add on when you've had a look at the first bit. But those 4 categories are the ones to really focus on, because those will be the ones that for the majority of farmers, for the vast majority of farmers, will be producing the majority of your emissions. And then also look at the opportunities for sequestration. So start with those, and then just have a look at what it looks like. And then think, well, what are the things that I can change? It may well be looking at doing some soil testing. It may well be going and digging a hole and looking at the condition of your soils. It may well be looking at things like nutrient management planning, looking at fertilizer use efficiency, all those sort of things. But starting point is just to put some data in and have a play with it. We're more than happy at Farm Carbon Toolkit. We're more than happy to provide that help and support as well, and also some understanding at the other end in terms of what it means. So so please let us know. We're here to help. That's what our reason for being is, really.
One of the things I found really useful when you're putting the data in is that, so chemically, you're measuring it by grams of active, which takes a bit of working out. Obviously glyphosate's quite easy, 360, but some of the others, it takes quite a bit of trawling through. And because with the calculator, whatever you put in, you can easily change. So I put in 3 tons of chemical active, and then I changed it by half a ton. Didn't actually make it much difference in the overall scheme of it. It's more the big things like fertilizer, and that's relatively easy to get that right. The fertilizer, and obviously the soil organic matter, that's on every field you have to take a judgment of where you are as an average. So the things that play into your hands you can do.
And the other way of doing it, if you haven't got any, and some farmers like to do this, if you haven't got any organic matter analysis at all, then what you can do is put in all of your emissions and then look at, well, what do I need to be doing in terms of organic matter gain to be at net zero? And then you can start to use a judgment. Well, are the practices that I'm doing likely to be providing that or not? And you can be optimistic or pessimistic, and you can do it. So even if you've got no tests, you can just start to look, well, what do I need to do to balance this out?
Do you think in the future is there something in place at the moment with like remote sensing to measure organic matter in soils? Because obviously if we're doing various things to calculate it and having soil tests done, and then the satellite flies over and says, well, no, that's not what we think. you know, how accurate are those remote sensing tools?
We've just been doing a bit of a project on this, looking at the use of remote sensing, looking at the use of LiDAR, and also looking at some of these soil scanners that are available, that you know, that are also looking at variations in soil texture and looking at nutrient zones and all that sort of thing, because some of those are starting to look at using you know, reporting on carbon as well. And because of the we've got the fields that we've been working on with soil carbon projects, and some of those we've got like 100 points across the field that we've measured soil organic carbon in. They're a brilliant test bed to sort of see whether it works. And we've not found great correlation so far with the remote sensing data, unfortunately. You know, even in the top, you know, because we're measuring 0 to 10, 10 to 30, and 30 to 50, and I think we were never thinking we were going to get any of those deeper levels, but we were hoping that we might be able to get a little bit of correlation on the top. It's not great so far, and even with some of those, the scanning technologies, it's really important. Even there, they're still calibrating, so they're still taking a number of samples in order to calibrate those maps. So we're never going to get away from soil sampling, but I am really hopeful that as we get better understanding of how we can start to use some of these remote sensing options, that it will work. There are people using them over in the States, and there are people using them in Australia, and I've had conversations with various different companies that do that over there that promise me that it works. When I've said, well, we can't make it work over here, they say, no, we can. So again, we're going to try some of these different options to see, you know, to see whether they do work. So it's about trial and error, because again, if we can start to use some of these new technologies, then it does, you know, it does make the whole thing a little bit easier to understand, especially at that landscape scale. You know, when we're starting to look at how we can aggregate these things together.
I'll make this the last one because I'm conscious of time, and most are still here, so they're quite riveted by this, but I'm conscious it's your time as well. Do you think DEFRA will be in a situation to measure methane emissions, and hence work out where our reductions are going forward in the near future? Because obviously they're doing ammonia, you know, capture in towns and built up areas where it's mixing with exhaust from vehicles and diesel especially. Do you think they're going to start turning their attention to methane, you know, because it is our big Achilles heel in agriculture?
I don't think DEFRA are gonna measure it specifically. I think that, you know, there are some brilliant research institutes that we've got. Reading do fantastic work looking at dairy cattle, as do Crichton up in Scotland. We've got Rothamsted at Northwick, and then Chuggers over in Ireland, who are both, you know, they have these great sort of like backpacks that they put on the cows and sheep that have a little tube that comes down, and they can capture all of those emissions and start to understand in a lot more detail what those contributory factors are in terms of reducing methane. There's a lot more work going on at methane at the moment in the research community, and some of that is starting to come through, as I was saying about the work around breeding and its heritability. Also work looking at different feed supplements. There's been lots of work looking at how those could be used to you know, to suppress methane production. So I think DEFRA probably have funded some of that research, and they will look at it in more detail, I think, but I don't think we've got to the stage yet where we've got a sort of you know, sort of small bit of equipment that could be used out on farm by DEFRA. But certainly it's one of the puzzles that is keeping the research community busy at the moment, in terms of how do we navigate methane in the future. And what's quite interesting is that if you look globally at some of those economies where agriculture is a big percentage of their economy, like New Zealand, for example, or Ireland, you know, those governments are funding a lot of research because they sort of understand that if they don't do something about methane, then obviously they're never going to achieve their net zero ambitions. Now, New Zealand's interesting because they've got a derogation at the moment on methane, and they're using the new way of measuring it. So again, you know, we can start to look at how that set a precedent for these sort of things. And it may well be that in the future we actually split out emissions from agriculture in terms of biogenic emissions, so there's emissions that are part of those biological cycles, and fossil fuel based emissions, and we deal with them completely separately.
Well, thank you for a really interesting evening, and I think, you know, there's a lot to be learned yet, and I think farmers have got a lot of the answers. I'm just extremely cautious that we don't rush into selling our carbon too soon and someone taking advantage of us yet again, and we're becoming a price taker for sequestration of carbon. It does need measuring properly, it does need marketing properly, but I think we're one of the few industries that can really make a big difference, not only on our emissions but our sequestration. So thank you ever so much for tonight, Becky. I really enjoyed it. I hope everybody else has. Hope they've got something from it, even if you don't implement any of it straight away. Just hopefully we've got you thinking about it and starting to look at where it's coming from and measuring it. And I say again, the carbon cutting audit is the best audit I've ever done. I really enjoyed it. I'm really looking forward to doing it again shortly. And I really get you to all to have a look at it. A few of people I know within our cluster have had a look already and said it's not a bad audit. They really enjoyed it. So thank you everybody for taking part. Next week, we're going to be looking at history under your soil. So that's going to be quite interesting and something I've looked at, and it's quite a lot happening in some places that you didn't really realize what was under your field. So thank you very much, and we'll hopefully see some of you next week.